Video. Turn off the waiting room. So that shows up. Just share your screen. All right, so this unit is all about chemical equations. So far, all we've talked about are chemicals that already exist. Things like, compounds, elements, mixtures, things like that. What we're about to do now is show how these things change, how these things can combine, break apart, and make new elements. Every chemical reaction starts with compounds breaking apart, atoms rearranging, and compounds coming back together into new and different compounds. So this is kind of the basis for chemistry in everything that we do. So I got an example up here. I like this example because it's one of the simplest examples that we can use. We are all very familiar with water. It is the reason that there's life here on Earth, is that molecule right there. We're also very familiar with oxygen. That's what we're filtering out of the air. And most of us are probably pretty familiar with hydrogen gas. Hydrogen gas is an explosive gas. It's what made the Hindenburg explode, but it's also the most common element in the entire universe. So we have the most common element in the universe, what we breathe to live. And if you take those two gases together with enough energy, you can combine them to make water. So first thing we need to do is understand that this does happen. You can have a situation where you take a molecule of hydrogen, which is two hydrogens bound together, a molecule of oxygen, which is two oxygens bound together, put enough energy to it so that the molecules break apart and then they reform as water. But we got a problem because there's a law in chemistry that we have to follow. Remember back to the beginning of the year, we talked about laws and theories. Theories are the science, it's what we learn. Laws are the way that we're able to do the science, rules that are never broken. And one of the laws is called the law of conservation of matter. We know what matter is, right? Everything. What is conservation? If you conserve something, what are you doing?
Saving it.
You're saving it. You're not letting it go away. Okay? So the law of conservation of matter says that matter can neither be created nor destroyed. You can't make atoms from nowhere, and you can't make atoms poof into nothingness. So let's look at what we have here. Hydrogen, we have two atoms. Oxygen, we have two atoms. After the reaction, we have H2O. Does anybody see a problem?
There's not two hydrogen or two oxygen.
Yeah, what happened? We have disappeared in oxygen, and oxygen has poofed out of existence. Is that possible?
No.
No. So this reaction up here on the board is what's called a skeleton reaction. And it's called a skeleton reaction because it doesn't follow the law of conservation of mass, which means it is pretty much useless to us to do any math or anything else with chemistry with it, because this isn't really what happens, because it can't happen like this because you can't make an oxygen poof. Okay? You also can't just add an O over here, because an oxygen is never going to exist by itself. It's going to want to be in a bond. So we got a problem. We got to solve that problem. Okay? How you solve problems when you have a skeleton equation, when you have an equation that doesn't work, is you balance it. Now, here's something I want you to tell me, do you think I'm going to be able to do this right here? Because the easiest way to balance this is to just go right over here and put a 2.
But
Go ahead.
what happens to the other hydrogen?
2 hydrogens, 2 hydrogens.
But so then the two hydrogens combine to make one big one? Because look, in the third diagram.
1, 2 hydrogens, 1, 2 hydrogens.
Oh, I thought the blue one was oxygen.
Okay, now if I was to draw a picture of what I just did, I guess I could draw it like, I don't really know what the structure is, I'm just kind of guessing, like that. Okay? Here's the problem with it, and this is a really corny chemistry joke. Ready for a really corny chemistry joke?
Here comes the ad jokes.
Okay, 2 chemists walk into a bar. The first one says, I'll have H2O. What did the bartender give him?
Water.
Water. The second chemist said, I'll have H2O2. That chemist died. Because H2O2 is not water. H2O2 is hydrogen peroxide. If you drink hydrogen peroxide, it's poison. Okay?
Yeah.
So H2O2 is not water. So can I just put a 2 here on the end and make it water? No, I cannot do that. That is breaking a rule of chemistry. I can't change what I have. So the first thing you need to understand about balancing chemical equations is you don't mess with the subscripts. You cannot change the subscripts, because when you change the subscript, you change what you have. I gotta have H2, I gotta have O2, and I gotta have H2O. But what I can do is get more of them. Okay, so my first problem is I need another oxygen. I need another oxygen. Well, to get another oxygen, I'm also going to need what bound to it. I can't just get another oxygen. I have to have another of everything. I have to have 2 hydrogens bound to it. Now, how am I going to say that I have 2 H2Os?
H in parentheses and then put 2 outside.
Now, that's the way we did it when we did the names. You put a parentheses and put a 2 subscript. The problem with that is that's showing that they're still bound together. I don't need to show that they're bound together. I just need to show that I have 2 of them. And how you do that is you write a coefficient. This is called a coefficient. And you put it as a big number in front of your molecule. And what that means is that you have 2 of everything behind it. So you have 2 H2Os. Now let's see if we're balanced. What problem do we have now? Our oxygen is good, right? 2 oxygens, 2 oxygens. But what about hydrogen? How many hydrogens do we have over there? 2. How many hydrogens do we have here? 4. So to solve that problem, I'm going to do the same thing. I'm going to get another molecule of hydrogen, and to show that, I just put a big pretty coefficient from a hydrogen. So to balance chemical equations, what you do is you add coefficients to your equations until everybody is happy. Now, once you're balanced, I strongly encourage everyone to always stop and check. How many hydrogens do I have here? 2 sets of 2. 4. 2 sets of 2. 4. How many oxygens?
2.
And how many oxygens?
2. No.
2 sets of 1, which is
2.
Who's happy?
Both of them.
Everybody. So we're done. We're good. Feel good? And so this unit today, we're just going to look at how to balance these chemical equations. Let me get the first example off of your practice for today. All right, first example of your practice has NaClO3, sodium chlorate, and that breaks apart into salt and oxygen. The easiest way that I've found to balance is to just go element by element and make it balanced using coefficients. You might have to change them because they might get odd. Okay. The only thing that I kind of put a caveat with that is if you have an element that's in more than one spot, save it for last. And I'll show you an example of that in a second. If you have an element that's more than one spot, save it for last. For this one, nothing's in more than one spot, so we're just going to rock and roll. How many sodiums?
1.
What do we need to do? What do we need to do to make that balanced? What do we need to do to make 1 and 1 balanced?
Nothing.
Nothing. It's already balanced. How many chlorines?
1. Balance.
Okay. How many oxygens?
O3 and O2.
Ooh. So now we have a little challenge. How do you make 3 and 2 the same number?
You add, no, wait, you can either reduce or you can add an additional element.
Okay, so let's talk about it. Is it possible to reduce in what we're talking about?
No.
No.
So you
We
have to
can't
add,
reduce.
you have to add an additional element that wants to give up one electron.
No, we're not making bonds. We have what's on the board. I hear you, and you're not wrong when we're making bonds, but the bonds have already made.
You have to add another oxygen molecule.
I can't just add an oxygen molecule though, because how do I can't just I can't just make that 2 or 3, because O3 is not oxygen, it's ozone.
Oh,
So I need take it back to math just a little bit. It's really, really easy math. My nephew's in 4th grade. He does this math. Y'all can handle it. I gotta find a common multiple, not a common denominator, a common multiple. Okay, what is the common
6.
multiple of 2 and 3?
6.
6. How do I make a 3 a 6?
Multiply by 2.
How do I make a 2 a 6?
3.
Everybody with me?
So it'd be NaCl plus 3O2.
Okay, so let's one at a time. Oxygen, we have 2 sets of 3, which is 2 sets of 3 is 6. And then over here we have 3 sets of 2,
Wait, what do we have to put
which
in
is
for-
also
what do we have to
a
put in
6.
parentheses?
You never add parentheses when you're balancing, because parentheses are within your molecule. You never add parentheses when you're balancing. Okay, but now I've created a problem. How many sodiums do I have now?
2. You only have 1.
Piece of cake to fix.
You had to have a 2 in front of it.
There you go. And that also fixed my
Your whatever that is.
chlorine.
Yeah.
Piece of cake. All right, let's try a big one. Let's say we got some magnesium sulfate, and we're adding it to some salt. We got a double replacement reaction. We'll talk about that next week. We end up with magnesium chloride and sodium sulfate. All right, so let's do it one at a time. Ladarius, how many magnesiums? How many mgs? Say it loud. Rock and roll. How many mgs? Rock and roll. You need to do anything? I might come back to you though, okay? Ashley, how many sulfurs? Oh, I'm sorry. I misunderstood you the first time. How many sulfurs? Nope. 1. The 4 goes to the what?
Oxygen.
4 goes to the oxygen. You with me? 1 sulfur here. Beautiful. Tell us. They already told you how many oxygens. What? Yeah. Rock and roll. We're kicking tires, lighting fires. Martin, how many sodiums?
Sodium, it's only 1 right now. But that's not even a sodium.
It ain't a sodium.
That's 2.
Very good. How do I make 1 a 2?
A reduction.
How do I make 1 a 2?
Oh, add the 2.
I'm not adding ever. How do I make 1? You're right. I'm going to put a 2, but I'm not adding it. I'm
Correct.
multiplying.
Huh?
Okay, yeah. How do you turn a 1 into a 2?
Multiply 1 by 2.
You with me?
Yeah.
So I'm about to put a 2 with this one or with that one?
That one, the one, first one.
The left or the right?
Left.
Right, very good. Feel good?
Yeah.
Okay. And then to Nyla, how many chlorines now? Martin just changed it. Very good. Let's go back and double check, make sure we didn't screw up anything. 1 magnesium, 1 sulfur, 4 oxygens, 2 sodiums, 2 chlorines, 2 chlorines. Yeah. All we had to do to answer this question was to write 1, 2. Make sense? All right. Let me see if I can do make a weird one off the top of my head. Yeah, I can do a weird one. Let's burn something. Let's burn some butane. So we have some butane, which is in your lighter. That's what a molecule of butane looks like. To make the butane work, all you do is add it to oxygen and put some energy with your thumb. And then coming out of it, you're going to get energy, which is not really an element, but you're also going to make some carbon dioxide and some water. All right.
Water to moisture.
So anytime you burn anything, you make carbon dioxide and water. That's how it works. Okay. Now this is where we hit something interesting because you see that you have oxygen in more than one place on the right. So I'm going to save oxygen for last. Everybody cool? All right, Mr. Styron, how many carbons?
3, 1.
Fix it.
Add a 3 in front of the CO2.
Very good. All right. Tanila, how many hydrogens? 8. Very good. Loving it. Good job. All right, Martin. The only thing I have left is oxygen. We saved it for last anyway. How many oxygens?
There's 2 over there, 1 on that side.
Very good. 2 on the left. There's way more than 1 on the right.
Huh? Oh, 4. 4.
There's way more than 4.
4 sets of H2O.
There's 4 here, but there's another place with oxygen.
There's 7.
How many oxygens right here?
Oh no, 6. There's 2 there.
6 here, and
4 there.
how many oxygens?
10.
Very good. Make that 10.
Put a 10 in front of it.
That would make it 20.
Put a 5 in front of it.
Very good.
Multiplication.
Kicking tires, lighting fires. Very good, Martin. 3 carbons, 3 carbons, 8 hydrogens, 8 hydrogens, 10 oxygens. 6 plus 4 is 10 oxygens. All right, let's do one more.
For this assignment, can we write it on paper?
Sure, absolutely, absolutely. Let's try. I'm doing with parentheses in it. Doesn't matter. Supposed to be 4. Y'all gonna let me write something weird. Yeah, it's supposed to be 4. My bad. Alright. That was that side of the room, going to this side of the room. Ready, TJ? Think before you answer. How many N's? How many nitrogens? Very good. There's 1 in the parentheses, and you got 2 sets. 2. Feel good? How many nitrogens here? Just 1. How do you make a 1 and 2? Multiply by 2. Feel good? All right. Ashley, think before you answer. How many hydrogens? Very good. How many hydrogens? Very good. There you were 4, but TJ changed it to 8. Excellent, excellent. Oxygens, Laderick? Fix it. Very good. Now we're going to screw up the world, though, because we're going to have to put a 2.
In the back.
Now you always put the numbers all the way to the front. So to get 2 of these oxygens, I'm going to have to put a 2. You with me?
That whole thing, one thing.
That's going to change this whole thing. Okay? So we'll get there in a second. We'll go back in a second. And then chlorine, styrene.
Oh, there's 2 of them.
Very good, very good. All right, but now we got to go back because Derek changed this up. He did what he's supposed to do, but he changed this up. How many nitrogens now, TJ? There were 2, but Laderick just multiplied by 2. So how much we got? Rock and roll. And you only made this one 2, right? So what do you need to do? Instead of multiplying by 2, you need to multiply by. Very good. Ashley, let's see if he helped you out. We had how many? Now we have, remember our multiplication tables? 8 times 2. Very good. 4 times 4 is 16. 2 oxygens, 2 chlorines, but now how many chlorines, Tyler?
There's 4 on that side. So you're gonna have to put a 2 in front of the other one.
Excellent. How we feeling?
Decent.
It's not that bad, is it? All right, practice is up on the board. Let me know if you need me. Go, 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 go.
I use the bathroom.
Sure.